students. Welcome back to the second session of online classes. I hope you all are safe and sound. There will be no nearby hope to run the school with your presence. So it's better to start learning in the online without bringing any gap between you and the education. Once again, welcome back. Now I am going to recall what I discussed in the previous session. So I started with the chapter motion. Motion tells about when object is moving or rest. It is in the state of rest. Here, an object which cannot move, those objects known as rest. Then object which can move, they are known as motion. They are in motion. After recalling the motion, objects which are at rest and objects which are in motion, we can define the motion. Motion can be defined as the change in the position with respect to time. So this is the definition of the motion. Motion can be defined as change in position with respect to time. In motion, very important concept is that motion is relative. The rest and motion are relative terms. They both are relative terms. It means when object is rest with respect to another object. An object may appear to moving from one person and stationary for some other person. Take an example in this picture. This girl is looking outside from the window a moving train. So she feels that the outside environment, the outside world is moving with respect to her. But here we can see in the bus, when these two persons are sitting next to each other, so they both are at rest. But when we see from the outside, so they both are in motion. That's why the motion is relative. So this word is very important. In motion, the motion is relative. Comes to the types of motion. So many types of motions are there, and some motions are very complex. Complex means very difficult to understand, very difficult to analyze and explanations. But in class 9th we are having a very easy concepts. First, motion in a straight line. So if an object moves in a straight line, otherwise means it should not change its direction, just like in march past. So these all soldiers are moving in a straight line. So this kind of the motion we are known as straight line motion or motion in a straight line. This motion in straight line. Second motion known as rotatory motion, rotation. So this is the another type. If you can see here, the wheel is rotating around anti-clockwise direction, or the gearbox, here the gearbox also rotating. So this motion is known as rotatory motion. Another type of the motion is known as vibration. Vibration means moving back and forth. So just like swing, an object is moving back and forth like pendulum, moving back and forth. So this motion is known as vibratory motion. That is an example. This is one kind of a molecule. So in this, the atoms are the vibrating, they are the moving back and forth. So this motion is known as vibratory motion. So in this chapter we will learn only the straight line motion. Apart of that, all different types of the motions, we will strictly follow motion in straight line. So to describe the motion, first we have to set up a reference point or known as origin. So whenever you are describing a motion, you want to explain a motion, it means you have to move from a point or from a starting point. So that starting point we define as origin. So this origin only known as a reference point. Suppose at here you started to move. Let us see an example at here. Yeah. So in this one, this is your house. You wants to move to this grocery shop. Now you have to start from your house to reach grocery shop. So your house we have taken as reference point, the starting point where you are starting the motion. So that point we are known as reference point. Now you started from at here and you reach to a grocery shop at a distance between them 4.3 kilometer. So this your house we known as the reference point. Suppose you want to move your house to your friend's house, which is at a distance 2.1 kilometer. Again you have to start from your house. So your house we have taken as reference point. Reference point is easy to calculate the distance between the motion or calculate in motion. So let us define distance. Distance is the total path length covered by the object. The total path length, it means suppose you started from here. This point is called A, and all the way you started and you walk up to here and you reach a point B. So this total path length, bring a meter tape and measure from here to here. So this only we known as distance. Let us see an example at here. NCERT example. Suppose I started from O. And here I started from O and I reach up to at A. So in this first case, from O to A, what is the distance from the O to A? So from the O to A, the distance we have to calculate. So here the O we have taken as origin or reference point. Or starting point, all are same. Origin, reference point, starting point, all are same. And you started from O and you reach up to A. So the distance between O to A, here the 0 and here the 60. So distance between O to A is 60 kilometer. Okay, now see the question at here. The question is I started, so this is the question. I started from O, went up to A and back to B. Okay, I started from O and went up to A and back to B. So what is my path length? What is my path length or what is my distance that I walked? So from O to A, distance is 60 kilometers, and from A to B, you walk back. From A to B the distance is 25 kilometers. How do you know that? You can subtract from AB to get A to B. From figure, AB equal to OA minus OB. So I want the AB. OA is 60 and the OB is 35. So the distance between A to B equal to 25 kilometer. So O to A 60 kilometer and A to B 25 kilometer. The total path length is 85 kilometer. Now see the next concept known as displacement. Displacement. So it is the shortest distance. It is the shortest distance measured from the initial to the final position of an object is known as displacement. The shortest distance between initial and the final point is known as displacement. Let's see a small example. Suppose this is your house. This is your house and you want to reach your friend's house at here. Your friend's house at here. Okay. So this is your house. That's its name as A and its B as B. Now the distance, you can go all the way like this, you can cover so much distance and you reach up to at here, or you can choose from A to B like this, like this, like this, like this, and you can go your friend house at that. Or these two are the start. Or if you can take a straight line from here to direct at here your friend's house B. Now this is known as displacement. The shortest distance between your house to your friend's house is known as displacement. To make distance shortest, we have to follow only particular direction. So here the direction is very important. You have to move in this particular direction, then only you will reach your house, your friend's house, on particular direction. So we can define as displacement along moving direction. So that is the direction is very important. Now here one consideration, displacement along your moving direction is taken as a positive. If you are moving in the same direction, in that case we have to take the displacement positive. So to that understand, so let us take a small example. I will draw a number line. A number line which starts at 0 at here, 10 at here, and other side minus 10 at here. Suppose I am here, I am moving along in this direction. So when I am moving along in this direction, my displacement is positive. Okay. When you are moving opposite to the direction, you can take as the displacement is a negative. When you are moving opposite direction, that times you can take the displacement is negative. Positive displacement and negative displacement. Let us see it here. One question. Here I started at O. I started at O and went up to A and I came back to O. Now the question is, what is my total displacement? How can I calculate? From O to A. The distance is 60 kilometer positive. Sorry, the displacement is 60 kilometer positive from A to B, from A to O. Now you are the moving in backward direction. You have to move in backward direction. When you are moving in the backward directions, you will get the displacement negative minus 60 kilometer. So the total displacement will becomes the 0. It means where you start, there you reach. So the displacement is 0. Coming to uniform motion. Uniform motion is if an object covers equal distances in equal intervals of time is known as uniform motion. See the definition. If an object covers equal distances in equal intervals of time is known as uniform motion. See it here. A car starts at 9:30. This is the reference point, and 9:45, then after 10, then after 10:15. So here it mentioned that how much distance it covers. So between 9:30 to 9:45, it means 15 minutes. In 15 minutes, the car covered 10 meter. In another 15 minutes, again the car covered 10 meter, and next another 15 minutes, again the car covered 10 meters. If you can see, it covered equal distances all in equal intervals of time. Then we can say the car is moving in uniform motion. The car is moving in uniform motion. Coming to non-uniform motion, opposite. If an object covers unequal distance in equal intervals of time is known as non-uniform motion. Unequal distance in equal intervals of time. Suppose here you can see between 9:30 to 9:45 means 15 minutes time is there. In 15 minutes time, the car covered at a distance 19 minus 12 means it covered 7 meter. Let's take another 15 minutes from 9:45 am to 10 am. The car covered 23 minus 19 means it covered only 4 meter. So another 15 minutes of time, the car covered 35 minus 23, it means it covered 12 meter, and so on. So the car covered unequal distances in equal intervals of time. The car covered unequal distances in equal intervals of time is known as non-uniform motion. Let's see another concept, speed. Speed is a measurement how fast an object is in motion. How can we say the speed? Speed is how fast an object is moving. To calculate speed, we use a formula, speed equal to distance upon time. So by using this formula, we can measure the speed of a moving object. We will measure the speed in terms of meter per second. It is the SI unit, standard international unit. SI unit of speed is meter per second. So in vehicles, this instrument name is known as speedometer. This speedometer measures the speed of the vehicle at that particular time. So it is also known as the instantaneous speed. So it measures how fast a vehicle is moving. Let's see another concept, average speed. Average speed is defined as the total distance by total time taken. Average distance is defined as the total distance by total time taken. Let's see an example at here. So a runner is started at 9:30 a.m. and at 9:40 a.m. he covered 5 meter, and at 9:50 a.m. he covered 3 meter, and another 15 minutes, it means at 10 o'clock he covered 7 meter. So the time interval between is same, means 10 minutes each, but the distance covered in 10 minutes is different. In first 10 minutes, from 9:30 to 9:40, he covered 5 meter. 10 minutes. In another 10 minutes, he covered 3 meter. In another 10 minutes, he covered 7 meter. In another 10 minutes, he covered 5 meter. In last 10 minutes, he covered 15 meters. Now, if anybody asks what is the average speed of the runner, so we have to calculate the total time by total distance. Here the total time is 50 minutes and the total distance is 35. Meter. Therefore, the average speed by using the formula, the total distance by total time taken, you calculate the average speed. Here the total distance is 35 meter, total time 50 minutes. We will end up with the average speed of the runner 0.11 meter per second. Now remember this formula carefully. Average speed equal to total distance by total time taken. Average speed equal to total distance by total time taken. Now comes to the another concept, velocity. Speed is defines, just now we discussed about the speed, it defines how fast an object moves. But velocity defines how fast an object moves in given direction. So here the direction is important. Now just recall the concept of the displacement. Suppose you want to reach from your house to your friend's house, so the shortest distance is, this is the one which I shown it here. So now we say when you move from your house to your friend's house in that particular direction, we can able to calculate your velocity by using the formula. So velocity is nothing but speed in a given direction. Velocity is nothing but speed but in a given direction. So when you say a car travel at 60 km per hour, so here you are not specifying any speed and all, any direction, you are only specifying its speed. But when you say when a car moves 60 km per hour to the north, you are specifying its velocity. So the formula for velocity, is nothing but velocity equal to displacement upon time. The SI unit is, displacement units are meter and time units are second. It's nothing but meter per second. Similarly, average speed, how we calculate? Here also we need to calculate average velocity. The another formula for average velocity, another concept similar to average speed is average velocity. The average velocity equal to total distance by total time taken.